Edexcel Unit 1, Topic 5, Data and Databases. So when we compare the data and information, so informations are processed, organized, meaningful, decision-making, uh, information it provides. It's a processed set of data. So we can all data are processed into meaningful information. So we can classify two types of data: structured data and unstructured data. So structured data can be displayed in a row or column set of columns or relational databases, then arranged in a structured manner. We call structured data. So structured data example, numbers, dates, strings, then estimated 20% enterprise data or some kind of estimated figures are there. Then require less storage capacity if we are using structured data. Just think about the school student information. If you are going to save all the school information as files in cupboard, you will need the large set of cupboards to put all the files record student records. But if you use this set of database, you need less number of space to store. Actually, use the pen drive element. But if you arrange it structured manner like database, it will more simpler because same data is not going to repeat. For example, phone number. If we are going to update the phone number, it automatically updates. And there's no duplicate. And there are primary keys linked between, for example, then there are two children living the same, two sisters and brothers. So if the parent contact number, no need to repeat again. So from the database, directly can take the siblings information without duplicating. Okay, so like we can take structured data, then easier to manage and protect with the legally solution, legacy solution. So then we can structurally maintain that data, but unstructured data cannot be displayed in a row or columns related relational database. So we can't make some kind of cross columns according to the unstructured. There's no better plan. So images, audio, video, word processing files, emails, spreadsheets are considered as a structured data. Estimated 80% of the enterprise data are considered as unstructured data. Then requires more storage capacity when we consider the unstructured data. Just think you are going to collect all the school student information into Excel sheet. Okay, obviously it's really hard. But if you feed data to the database, then less amount of space needed, and you can clearly figure out. For example, I can remember that when you were small in grade 8 or 9, that school wanted to get some insurance. That means government insurance policies were there. End of your textbook, there was something, I can't remember the name. Isuru something. Okay. So therefore that entire school has to be computerized. And all the student information, phone numbers, whereas ID numbers, everything. So we, myself and two teachers get together and entered all the information into the Excel sheet. Okay. So there were some duplicates as well. By the same family, siblings are there. The records are duplicating. So instead of that Excel sheet, if we can feed data to the database, we need less records because there are siblings as well as parents are some are in the staff members. Then it's directly can link between with the primary case. That means with the help of identity card number. Okay, so it's better to use a database instead of Excel sheet. Then require more storage space if you are using the uh, normal Excel sheet or unstructured data. More difficult to manage and protect with the legacy solution. So it's difficult for us to get some decision-making solution in such situation with the unstructured data. So definition framework. Data definition framework, there are again two types, structured and unstructured. Human generated, that means structured data format, human generated surveys rating, aptitude, questionnaires like internally collect some data. Then machine generated data formats are web metrics, web blogs, product purchase from the sales records, process control measures are there in the machine generated data. Then human generated data we can take in structured manner, numbers, uh, retweeters, Facebook, Twitter should be there. Twitters, Facebook, Google, like plus, one plus, rating, Yelp, patient, patient rating rates. So those things you can take external, some kind of social feedback we can take this side. And those are the sources, data sources, the places where you can gather. Then machine generated data, GPS, then time off, then update, positioning. Now, if you are using the Google Map, directly can gather the information. So like external apps can be used, Google Map, like external apps can be used to generate the data. So we call machine generated data. Then human, if the human generated data, that means Facebook, social media groups, we can comment it out. So those are human generated data. Then internal, when we consider internal means human generated data, and the web metrics, blogs, process control, this part is internal. Unstructured one, human generated emails, letters, audio, transcript, customer comments, voicemails, corporates, video communication, pictures, those things we can take unstructured data. Human generated data contains of social media, updates, comments in online forum, comments on Yelp, then video reviews. Those are externally data gathering method. Okay. Value of information. In modern supply chain, information replace inventory. Why? So the value of information actually, I'll get the information helps reduce the variability, then improve the forecast, enable coding system, improve the customer service, facilitate lead time reduction. But value of information, not that much. There are more than that. Value of information decrease according to the time. Now look at this one. We call that as a golden rule of information. Golden rule of information graphically represent the value of information in it maximum level at the moment the information is created. Just think about the moment the all the result released. You got to know the results is releasing at, just imagine it's 3 p.m. Okay, so you got the message. The moment which it released, there is a high demand. Okay, so just think you are typing your number and it's buffering until it display the result 9s, until it display the 9s. The moment before, that means 2 or 3 5 seconds maybe there after you type the number and press the enter, and after that there may be 5 or 10 seconds. That time, just imagine how was the value of information. It's the big. Okay. As soon as you see, imagine that you got 9s. How was the demand of the information? Stop ranking. You may say, yeah, I passed the exam. I'm calling Amma, everyone. I have good results. You're calling everyone. The value of information in the top level. Okay. Yeah, then that's the time is close to the zero. But now a little bit reduced. Ne? Now no one is asking now. They rarely ask now what's the result. When you're passing the ALS with 3 years, who are there anyone ask? Will there anyone ask you, how about your ALS? Sometimes it will reduce all the time. Then you pass out the university with special and with a class, you pass out the university. Will there someone else sometimes, but little, not that much. The moment the information released, it had higher demand, but now reducing. Okay, so then it come to the close to the zero. So we call this one uh, as a golden rule of information. So the value of information equals according to time. Then the value of information lies in the ability to change that we decide and those decision change outcomes. So with the help of value of information, we are going to get the decision. Then decrease of information value. So decrease of information value as soon as it released and the realize how it is happening. So the meaningfulness of the information, whether it can be realized by the another person, understandability. Okay, then probable, that means just look at performance gap based on your current capabilities and execution. Probable, then based on your expected capabilities and plans. Potential, if you are applied to the data or relevant. Vision gap, I think this won't be coming for the exam just as it is I gave. Okay, it is there in the seminar one. So realize mean understandability. Then this one should be uh, relevant to the individual based on your expected capabilities, whether it is relevant to the individual. Then if you are applied the data to all the relevant business process, so for what you are going to apply, it also should be relevant. So if I'm going to teach now, instead of AS, if I teach you the A2, AS, Edexcel theory is relevant. But is that relevant this moment? No, A2 is not needed now. Okay, like it should be relevant to the individual. Then changes and risk of dark data. Dark data, the changes and risk of the dark data. Outdated or inaccurate information. If the data is outdated or inaccurate, we call dark data. It's no longer needed. That means, for example, grade one Sinhala book, grade one mathematics book, English book, are you going to keep? No, that is outdated. Are you going to use those books for your studies now? No. Then higher storage and overhead cost. So another point that dark data features, it contains higher storage and overhead of cost. Then unused information, untapped potential. So that some informations are not going to use. We call it as dark data. Legal and regulatory issues. So there may be issues if you are going to use that. Legal issues, then security risk, access permission and challenges, longer backup windows and recovery potential features are there in the dark data and it contains the risk. The cause of dark data, 20% is visible in structured manner, spreadsheet, CSV files, databases, but some dark data hidden. So semi-structured one, invoice, contract, purchase orders, and unstructured one, emails, voice, videos, like those are hidden one. Why databases prefer unstructured data? Sorry, why databases prefer structured data? Okay, so we are going to compare structured and unstructured data with the preference. Structured was unstructured data. Okay, structured was unstructured data. So structured data is used for the database. Database management, DBMS. Database management uses structured data. So why we are using structured data? We are going to compare the difference and importance of them. So structured data standard for information that is highly organized, factual, and to the point. So it is highly organized and it provides us a precise information. Okay, so questionnative. So can use some for questionnaires I directly. And while it is something like quantitative, it measure values can be countable, but we'll compare both together. Qualitative means some kind of features. If I ask whether the data age, that is quantitative. That is, we can question and get the clear answer. So questionnaires we use for quantitative data. So directly we can get some kind of precise, accurate answer. But the qualitative, if I ask who is the beautiful girl in the class, can we say? Can't. It's a quality. Okay. Who is the fair boy in the class? Difficult. So those things are quality. So the data containing qualitative data and quantitative data, there are two types. So when we are going to ask some questions, so we will be in trouble. So it's better to have the data in quantitative. So sound volume, if there's a volume level, then quantitative. If there's no volume, high or low, something like that, then qualitative. Qualitative data cannot measure, but quantitative data can measure with some figures, values, numbers, numerically measured in the structural data. This structured data represented in the numerical method we call as quantitative. First point I didn't explain it. Unstructured data doesn't have the predefined structure to it and comes it in all its diversity of the form. So it comes in the different format. It may be some kind of video clip, database, Excel sheet, not database, Excel sheet, image, notepad, something like different formats are there, audio clips. But the structured data are very well organized and very qualitative, directly can answer, can make queries for it. So data warehouse, rational databases are there. That means we call it as especially relational, rational databases and relational. Between databases, there are link. So here, relation database means, for example, in school, student registration table is there. Then we can take teachers table, then timetable. So the timetable and the teacher table is linked together. Then student is entitled for the class. The student belongs to the class. So the class has this class timetable. Okay. So there is a link between tables. Okay. So we call relational database when the tables are linked together and can find out information. For example, if I consider my timetable in the school, I have altogether 7 classes for particular period. That means commerce section, math section, art section, bio section, English medium, math, bio, all 7 classes are joined together and given particular one teacher. Okay, so that means assume I have altogether 15 period per 13 period per week. So all 13 periods, that means ICT period, all the class students are coming together in that particular period. Then what is the primary key? My employee ID or teacher ID is the primary key there. It has taken as a unique value and that is shared with all 7 classes. Okay, so that means my time slot is not going to duplicate in a different time slot. එකම වෙලාවේ හැමෝටම එන්න දාන්න. මම නැත්තම් මොකද වෙන්නේ? So I have to teach all 40 periods every day. Then by making the primary key, then everyone linked together. So we call that as relational database. Then several predetermined formats are there in the structured one. But unstructured one, data leakage, non-relation database, repeated duplicates are there, huge array of formats are there. Structure of relation database. A relation database basically consists of number of tables. So there are many tables and these tables are linked together. Each of these is called a relation instead simply relation. Relation means join together. Then, for example, think you have siblings in the school. Elder brother, younger brother are there. So I want to take a call that in younger brother's record book, the phone number is not there. Okay. Or else, then I ask the admission number from a younger. So from the admission number, I can find out the parents' phone number or ID number. So there is a link between. Then I can identify who are the brothers, which class are they. Then can call them also by taking the information from the database. Each table contains a number of rows and numbers of columns. Each row is called tuple. So one particular row or record we call tuple. Another name, record. And each column is called attribute. Name, date of birth, address. Columns are attributes. So now customer name, customer street, customer cities are attributes. And the set of record, that means how many records are there? 1, 2, 3, 4. 4 records are there. So these records we call as tuples or rows. Components of the relational database. This is very important. Field name. Each and every field contains a name. So we call those field names as the attribute. Another name, attribute. That means features. Okay. Then this is key field. So key fields, keep in mind, should be underlined. They are not underlined. If it is a primary key, okay. So if it is a primary key, it must underline. Okay. So with the underline sign, we take it. And another thing, according to the Edexcel syllabus, if you have the foreign key, we use the asterisk mark. Just keep in mind, I'll give it later. Foreign key, we represent it asterisk mark. Then surname, date of birth are there. Another important thing, we are not going to insert age into the database. That's a common question. Why we are not going to insert the age? Yes. Time to time it's changed. Therefore, we are keeping only the date of birth in the database. So if we know the current date, we can subtract and get it, find out the age. Okay. So we use the date of birth to derive the age. The keyword derive. Derive the or retrieve the data from the date of birth. We retrieve the date or derive the date, age from the date of birth. Why is that? Search we use derive or retrieve the age from the date of birth by subtracting the from the current date. It was there in the local level also. So data items are these features. So a set of records are there. So entire thing we call as a table. Table also called relation. Yes, another name, table we call relation. So relational database means tables are joined together. So relation, another name, relation. So primary key, we are not going to represent primary key like that. We have to underline it, okay? So primary key we underline, and the primary key cannot be duplicate. Can there be another person with your identity card number? Can there another person with your phone number? Dual SIM, you can take another SIM, but for particular person can person can use that now. Okay. A composite key means join two keys together. For example, think there is a student in the Commerce 4 class. Okay, so his index number is number 5. He's coming to ICT, and according to my ICT table, his number is number 2. Okay, so now I want to call that particular student. I will call, think the name is Saman number 2, who is in the Commerce 4 class. So to derive that particular child, I use two primary keys. Two keys I use. Commerce 4 පන්තියේ ඉන්න IT කරන ළමයා කියන්නත් Commerce 4 පන්තියේ ඉන්න මගේ රෙජිස්ටරේ නැත්නම් ෆෝන් නම්බර් එක දෙනවා. මේ ෆෝන් නම්බර් එක තියෙන Commerce 4 ළමයා. Phone number is another set of primary key, some kind of key. Then the other one, Commerce 4 child, another key. Or else, I think there are two students with the Saman Pereira. The other one is Saman Fernando. Okay. So then I have to use both the name. Because to identify a particular child, I have to use two keys. First name and the last name. Both I have to use. Columns, we call another name attributes. Right? So total number of column is degree. So how many total number of columns are there? 3. So we call as degree. So total number of rows we call as cardinality. Cardinality means rows. Next one, primary key was foreign key. So primary key is uniquely identifiable key in the particular table, and foreign key is a primary key of another table, but it resides in this table. Got it? The primary Sri Lankan president is a primary key of Sri Lanka. Okay, so I think the foreign president, Indian president comes to Sri Lanka. Both of them sit together. Who is the primary key? Sri Lankan president. Who is the foreign key? Indian president. So Indian president is a foreign key in Sri Lanka, but when he resides in go out to that country, he is a primary key. Okay. If that particular key is, that means foreign key is a key of another table, but it resides in this table. But there is a primary key for this table. ලංකාවේ ජනාධිපති ගාව ඉන්නවා පිටරට ජනාධිපති. පිටරට ජනාධිපති foreign key එක වෙනවා. හරි? මම එහෙමයි Edexcel එකට එක ආයෙත් ඉන්නේ. හරි? So the primary key course ID is a primary key of this table. And student table primary key is a student ID. So once the student ID is calling from the student table, we have to take once the course ID taken from the student table, we are considering this one as the foreign key. Student table එකේ තිබ්බ primary key එක student ID. Then the course table primary key is the course ID. So we are calling this course ID to the student table. So that situation we call this one as the what? Foreign key. So normally we represent the foreign key with the asterisk mark. That's the standard way how we are representing this public. Just present with the asterisk sign. And primary key is underlined. Okay. Okay, then next you. Relationship between tables and entities. So student, teacher. Now just think about this class. How many entities are there? Teacher, student. Okay, but we write it in the single format. teacher is a one table. Yeah. If there are many teachers, even we use only one particular table. Teacher is a one table. Student is another table. One table. Therefore, we write teacher. That means if we want to insert our data to the database, what are we going to do? We are going to make two tables. One is teacher's information table. The other one is student information table. So then altogether then two tables. We call it two entities are there. Student and the teacher entity. Then one teacher is there, and now here we have three students are there. Okay. So one teacher, three students are there. So if there are three, then we can make it as 3 and 8. Okay. So if there is a one student, then we can say one student, one teacher. Just think about individual class. Only one student, one teacher. So we can represent teacher has a student. Okay, student has a teacher, both the side. So a student has a teacher has a student. Cardinality of the relation is 1 to 1. Participations are 1 in the teacher side, the other side 1. So if there are two teachers even, we represent in the singular format. Then relationship between the tables and entities, 1 to many. So many in Edexcel, we use something like this symbol. Okay, many represent it like this. Oh, in local, we use the M1. So this is many side, and the other side is 1. Okay, so many student has a teacher. Many student has a class. A class has many students. So even though there are many students, we use has in singular format normally. Normally, it's not a standard, but in Sri Lanka, we are writing in singular format. But at Edexcel, there's not a rule. If you want, you can write the have even. But student should be singular. Don't put the S. Why? In that particular table, there are multiple records. So can be many records. Therefore, we write the M, but it should be the singular form. In normal local syllabus, we call this has singular format should be there for the relationship. But Edexcel, no issue. Therefore, you can write have given for this one. So this is an entity, and this also entity. This one is the entity, and this also entity. And in the middle, what's that? That's a relationship. Has connection. The next one, relationship between the tables and entities, many to many. Cardinality of the relation is many to many. So many students, many sports. Okay, there are many students for many sports. So many student has, in local we use has. If you want, you can write have even, never mind. Many sports. Okay, many to many. Shall you write this one as well? So in M2M, many-to-many relationship, we are not going to use same letter. So M mean different types of variable. N mean different. Because if, for example, 5 to 5, if you use the same letter, then same exact number should be there. So if you use a different variable names, that means this can be 5, this can be 10, no issue. Okay. So the value can be changed. So if we are using MM mean, this must be 10. So to avoid that problem, we use different letters. Database Management System, DBMS, is a collection of programs that enables you to store, modify, and extract information from the database. So we can store, modify, and extract information. Example, MS Access, SQL, MySQL, Oracle, and DB2. So those are the database management system. So components of database management system. So the database is there. That is the place where we store the database. Then DBMS, database management system. It consists of design tools and time environment. So design tool contain database tables, forms, creation, query, report, procedural language, then runtime, form, process, query, process, report. Then application programs are there, user, developer side application programs, and user side user interfaces are there. Just write the heading components of the database management system and list these. That means database, only the highlighted one, no? Database management, application programs in developer user application. So DBMS subpoints better to take design tools and runtime. Number 1 database. Number 2 database management system. Under that, first point design tool, second point runtime. Then application programs, user interfaces. So together we call components of database management system. So it consists of the database management engine. Shall I write it there? That's easy for you. Database. Okay, the second one, DBMS. So DBMS, under that, we can take design tools, runtime environment, design tools, example, table, forms. Then other example, second point. Ne? Runtime. Then next one, application forms. In developer side. Then user interface. That is in the user side. Then I might. Okay. Then next one, I should write. So there is a standard one we call architecture, ANSYS Spark architecture. That is American National Standard Institute. They are the one who provide the ANSYS Spark architecture. So there's a physical level. We call that is a database. Then file system, database management system connecting the users. So externally users communicate with the database. And database DBMS is a conceptual level. Then internally data storages are there. Now we are going to move to the types of keys. Keys. The primary key constraint will uniquely identify each record in a database. So using primary key, we uniquely identify the records in the database. The primary key column cannot contain null values. It cannot be empty. Okay, constraint means limitation, SEMA, and some kind of rules regulation. Okay, so primary keys cannot be empty. It cannot contain null values. Then most tables should have the primary key, and each table can have only one primary key. But if there are two primary keys, we call composite keys. So null constraint means cannot keep null values. So null constraint is a rule of prevent all null values. That means we are not going to use null values. So you know that for that no need a note there. So primary key constraint uniquely identify the record of the table can have only one primary key consists of one single or multiple fields. Primary key is a candidate key that most appropriate to be maintained. I'll remove this upon it. Okay. So primary key it's a candidate key that is most appropriate to the main reference key. So it is a key which is going to call all the other attributes, that uniquely you can identify the record with the help of primary key. Unique, for example, national identity card numbers. All attributes depend on the primary key. That is very important. All attributes are depend on the primary key. I just want to check whether the null value is there in the that is the table name, and student ID is the primary key. It is already underlined. First name, last name, course ID are there. Okay, so those are the attributes. You better sketch the table, no need the value, and draw the lines. So primary key we can write like this. Just sketch the table. I'm not drawing the arrows because arrows are mean dependence. Therefore, I remove the arrows. Just foreign key, content of a relationship database. Foreign key is a field or collection of fields in the one table. Uniquely identifies on rows of another table. So foreign key is defined in a second table, but refers to the primary key in the first table. So primary key of a table used as a foreign key of another table to establish the relationship in a database. So actually, I'll remove this first. I'll remove this part. Okay. So foreign key is defined in a second table, but refers to the primary key in the first table. That means primary key of a table can be used as a foreign key of another table, not the same table. Okay. Establish the relationship of a database. There is an election. There is an election. Okay. So for the election, there are candidates from each province. President election, just think for the presidential election, the candidates are there from each province. So the selected candidates we call candidate. Out of these candidates, only one president has selected. So we call that president as the primary key. Okay, but the rest of the people who couldn't select as a president, we call them as alternate keys. There are uniquely identifiable keys we call candidate keys. They can represent the records individually. So we call candidate keys. Out of those candidate keys, one special key is selected as a uniquely identifiable key. So that is a primary key. The rest of unselected candidate keys we call as alternate key. Okay. So all are candidate keys. Candidate keys so from that, they check in the one who selected, we take it as primary. So those students, we take it as alternative key. So candidate key is a column or set of columns in a table that can uniquely identify a database table records without referring to any other data. Can uniquely identify a set of records without referring to any other data. Each table may have one or more than candidate keys, but one candidate is special one, and it is called the primary key. The one candidate is special, it's called the primary key. This is usually best among the other candidate keys. It's the best one. So alternative keys is associated with one or more columns. Those values uniquely identify every rows in a table, which is not a primary key. And it is a candidate key. Alternative key also candidate key. Okay. Shall I write? Both same, both same. Both thing we are that also special key. So both are same. Chand illan election illu prati candidates la. Lekin theories checkina president kene primary key. Theories nati illu prati alternative keys. Right out la. And it's better to sketch this one. No need the records, just the attributes. Okay. Number side key. So primary key consists of more than one attribute. The primary key consists of more than one attribute. So here composite key, student ID, subject ID, both together we call composite key. So relations key, okay. For this one, we are writing here, the table name is student. Student subject, okay. So we can write it here. Normally, composite keys are used for the relations. So student ID, we will copy down first part. More than one keys, one attributes are in the primary key. We call composite key. Joining, composite will join together. And here you better underline these two together. Another important thing when you're writing attributes, did you check I didn't put any space? Okay, don't put the space in the attributes. Okay, yeah, you have the underline, underscore is there. So no space between there because we can't write the SQL code with the space. It's not executing. Therefore, don't give the space in between attributes. So relation schemas represent the table name, attributes with brackets. So instead of writing entire table, we use relation schema in Word. So example. Constraints. So there are some limitation rules we are using in the database. First one, key constraint. We use a primary key. We call it as key constraint. Second one, domain constraint. So limitation, size. the number of digits for the name. So number of digit size limitation, date type, we take it as the data type, we take it as the domain constraint. Then next one, foreign key. The referential integrity constraint is the foreign key. So that means it is a foreign key, it is a primary key. That means that foreign key is a primary key of another table, but residing in the same another table. So therefore, foreign key we take it as a referential integrity constraint. As a result of foreign key, we can connect two tables. Our table is primary key connect. So we can take the information. For example, in Sri Lanka, Indian Prime Minister can give information about the India. When he is going to discuss with our president, then share the information like relation foreign keys are used to take the connection between the another table. That's all for the composite relation integrity constraint. I think only this one to write. So here we are going to discuss about the ER diagram. ER diagram means entity relationship diagrams. Okay, ER stands for entity relationship diagram. So ER diagrams are using when we are going to design the software. In designing view, I think you are the software engineer. You are going to build the system for the school. So you are going, you will get the information about school, student, and teachers information. Then you sketch the diagram. There should be a teacher table, student table, timetable table, books table. Like you will sketch. So that diagram, you are going to connect with each other table and with the relationship. How many students and how many teachers are ICT teacher, student, commerce class, how many student, math class, how many student, one to many relationship. So like mapping the entire actual situation, you are going to map into the database system. So that we call as interrelationship. That means the relationship between entities, teacher, student. So we can represent with the ER diagram like this. Okay. So attributes we use the oval shape, entity we will use the square, rectangle shape. So ER diagrams are frequently used during the designing stage of a development process in order to identify different system elements and their relationship with each other. I think you may know about the system development life cycle. System development life cycle means think you are getting a project. I'm asking, okay, I'll pay you 1 lakh. Can you make the timetable system for error section? Okay, so I'm hiring you. Then what are you going to do? You gather the information, find out the facts about the school timetable, by which kind of subjects are there, what are the combination, what are the basket subjects, what are the main subjects, like that. You will gather the information. So we call it as identification. Then you analyze. Okay, the budget, how they are paying 1 lakh. So therefore, no need to purchase new softwares. That means the operating system. So the things which you have to use it in your laptop and the softwares. No need to buy a new computer for that purpose, giving only 1 lakh. So have to analyze the budget and whether the school will be able to use the Excel sheet or database. If you are going to use hard software thing, you are going to use Mac. School, no Mac computers. Then it's better to use the Windows Mac. So like you analyze, then you sketch it. That means the entire one, which kind of tables should be there, you are going to sketch it. Then you are going to identify how many teachers, how many students, what to be relationship. So that design is in the design level. Then convert into SQL codes, program it, test it, deploy, hand over the product to the user. Then user is using. While using, there may be main feedbacks. That means request for the maintain. So you have to do the maintenance. Then again another cycle is start. So we call entire cycle as a system development life cycle. There are 7 stages: identification, analyze, designing, implement. That means development, deployment, development, testing, deployment, and handover. That means deployment and maintenance. Okay. So after coding, there must be the testing. Keep in mind. So those 7 stages are running. in the system development lifecycle. So this one is belongs to the designing phase. Still coding does not start, just designing and get the approval, gather the information and sketch it. So first one is we are using mainly three. So ER diagram symbols and notation. First one entity. So if the another one attribute. Attribute means tables, student table. Attribute student name. Relationship has play the relation what is available. So weak entity means this entity is dependent on other entity. So we represent it double lines. Weak attributes depend on another attribute. Weak relationship, if the entities are weak, then relationship obviously it become weak. Then that's the same thing. There are three basic elements of ER: entity, attribute, relationship. There are more elements which are based on the main element. There are weak entity, multi-valued attributes. Multi-valued mean if you have multiple phone numbers, so represent that we use multi-valued. Then derived mean date of birth. Age is derived from the date of birth, so we call derived attributes. Weak relationship means the relationship is depend on that both the side there are weak entities are there, then weak relationship. Recursive mean student, the prefect is a student. That means lead a student. Student lead a student. Same person looking after the same person. Okay, student is a person. Student look after student. Teacher supervise teachers. In the section head, think about section head. Section head is a teacher. Supervise teachers. Same thing has another relation with the same thing. We call it as recursive. This one. Okay. Employee supervise the employee. Okay, so we'll write only 2 slides and stop it. This one and this. Week mean depends. For example, we are going on a party, father's party, office party. Okay, so you are depend on the father. You can't go to the party without your father. Okay, so you will call Mr. Pereira. So you are the Mr. Pereira's son. So Mr. Pereira keyword should be there to call you. What kata karana? Tata nami tamai kata karana. Eage puta. Huh? Can't call directly. So that attribute entities depend on the strong entities primary key. That's what I did. I said, can't call your name directly. Your name is depend on the father's primary key. Therefore, weak entities depend on the strong entities primary. Cannot represent its own.